Okay, fine. Because of power issue, my servers are down. We are seeing the practical of guys. What was the last practical we were seeing? Pardon? Storage vMotion. Okay. Now there is no power there, so we'll wait for a moment. Once the servers are up, we'll see the practicals of enhanced vMotion. Okay. We have seen cold migration. We have seen vMotion. We're trying to see storage vMotion, and the next one is enhanced vMotion. So enhanced vMotion can be performed only through web client. So first we need to configure web client, then using a browser will get connected to our vCenter server, and from there we can perform enhanced vMotion. What is enhanced vMotion? Is that I can migrate a running virtual machine from one host to another host uh, without a shared storage required. For vMotion, my virtual machine should be on shared storage, but with enhanced vMotion, my virtual machine can also be on local storage, and I'll be able to migrate it from one host to another host. Technically speaking, in enhanced vMotion and storage vMotion both are occurring simultaneously. Okay, we'll see the practical. Practical is not that difficult. It is pretty simple and trivial. So let us start the new topics after that. That will be clustering, guys. Okay, very important topic. Okay, and we need to understand clusters. Now, guys, normally, why clustering service or clustering is used in IT infrastructure? Any idea why it is used?
For replication of data or
Uh,
sharing the data.
okay, fine. Basically, clustering is used to provide high availability or fault tolerance, what we normally call it. Okay. Now, normally, guys, if you want to provide high availability to a particular service or application, you configure clustering. And in order to configure clustering, you require two things. First, you require the clustering service. And the second you require is shared storage. That means your SAN. Okay. Now, without these two, you cannot configure cluster or do a clustering service. Okay. First, you require clustering service. Second is shared storage. Now, who is going to provide this clustering service? Normally, the operating system provides the clustering service, or else you can use certain third-party applications. For example, Microsoft Windows Server operating systems do have the clustering service, which is normally termed as Microsoft Clustering Service. Using this clustering service, you can provide high availability to services or applications running on your machine. For example, I can use Microsoft Clustering Service to provide high availability from a file server, from a print server, or I can also provide high availability to my Microsoft SQL database. Fine. So if you do not want to use the clustering service offered by your operating system, we can also go and offer third-party applications, clustering service applications like Veritas clusters. Veritas clusters is widely used in Linux and Unix infrastructures. So using those third-party application also, I can build a clustering infrastructure. All right. Now here, in our case, VMware vSphere also provides clustering service. Okay. However, the clustering offered by Microsoft clusters or Veritas clusters, when compared to that of VMware vSphere's cluster, there's a slight difference. All right. However, clustering service is required, and VMware vSphere offers the clustering service. Now, what is a cluster? Cluster means group. Okay. And what happens in a cluster? If you configure a cluster in your infrastructure, is that if you want to define a cluster, I've defined that in this way. It's a general perspective or general definition, or you can generally define that in this way. Group of servers or hosts working together as one to provide high availability. So this is a general understanding of clusters. Group of servers working together as one to provide high availability. This is a general perspective. However, VMware defines virtualization as group of ESXi hosts and its virtual machines. Okay, group of ESXi hosts and virtual machines on which HA or DRS is enabled. Now, what is this HA and DRS? Now, VMware vSphere clustering service has two features. The first one is called as HA, high availability, and the second feature is DRS, distributed resource scheduler. So, group of hosts, ESXi hosts and virtual machines on which HA, DRS or both are enabled, then that is called as a cluster. Cluster means group, okay, group of servers. Now here in vSphere infrastructure, the cluster is configured, managed, and monitored at vCenter level. So without vCenter, you cannot configure the clustering service of VMware vSphere. You cannot manage it, nor you can monitor it. So what is required first? You require vCenter server. So I have vCenter, let us say. Let us discuss the first HA feature of our clustering service. Now, HA, I configure HA, let us say, high availability cluster. Now, cluster means group, so that means I need to add host to this particular cluster. Let us say in my infrastructure, I have 4 ESXi hosts. So on vCenter server, I configure HA cluster. Then I add the host to my HA cluster. In this way. Now, whenever I add an ESXi host to my HA cluster, an HA agent gets installed on each and every ESXi host. What is happening? An HA agent is getting installed on each and every ESXi host. This is my HA agent. Okay. Just now we had tried to understand what is a cluster. Group of servers working together as one to provide high availability. Now what HA does here, or VMware vSphere HA feature? It provides high availability. But high availability to whom? Guys, in virtual infrastructure, is ESXi important or the virtual machines from the end user's perspective? Which is important, guys?
Virtual machines.
Virtual machines are important. Why? Because the end user's applications, the end user's services are running on top of my virtual machines. Okay. So HA provides high availability against host failures. What is the meaning of it? Let us try to understand. Let us say on ESXi1, I have certain virtual machines running. Let us say I have VM1, 2, okay, I have 3 and 4 here. Let's say I have virtual machine number 4 and 5, and let us say 6 and 7 in this way. 5, 6, 7. 5 and 6, 7 and 8. Okay, now what HA does here is that suppose there is a sudden crash of an ESXi host. Let's say ESXi1 is down. Then what will happen to these virtual machines, VM1 and VM2? Both will go down. Now, when these virtual machines will be back up and running? Guys, let us say ESXi1 is going down, then virtual machine number 1 and 2 are going down. So when would these virtual machines, VM1 and VM2, are going to be back up?
When the ESXi one is coming back, the host one is coming
yes,
back.
Yes, absolutely. When the ESXi1 is up, then VM1 and VM2 will be up. However, my ESXi1 may go down due to any reason. There might be multiple reasons why ESXi1 went down. Let us say ESXi1's motherboard has been crashed. Now we don't know when this motherboard is going to get replaced. We don't know when ESXi1 is going to be back up and running. It may take 5 hours, it may take 1 day, 2 days, 3 days, or a 4 day or a week. So are we going to wait for a week or 1 day, 2 day, 3 day in order to make my virtual machines back up and running? If that's the case, then my virtual machines are down. They'll not be up and running unless and until ESXi is up and running. So here comes HA, guys. If there is a sudden crash of an ESXi host, obviously the virtual machines are going down. However, what HA cluster is going to do is that it is going to restart the failed virtual machines on some other ESXi host within 3 minutes. This is what HA does. Whenever a host fails, suddenly, virtual machines on it which were running will go down, will fail. However, they'll get restarted on some other ESXi host within 3 minutes. You got the point, guys, what HA does? So this is the first thing what HA does. It provides high availability against host failures. Fine. Now,
how do we know which ESXi is starting the machines on?
They get restarted randomly, okay, and HA is going to select the host. Fine. And we can find out on which particular host this virtual machine got powered on by going and seeing into the summary of the virtual machine. We can easily identify that. Okay.
Yeah. So it starts by itself, so it comes back.
Yeah.
On.
Yes.
Okay.
So here the virtual machines are getting restarted automatically on some other ESXi host in your infrastructure. Now, I told you clustering is possible only if you have a clustering service and the shared storage. Let me discuss the third component in clustering. Though I'm calling it as a third component, but it is called as heartbeat network. The third important thing it depends on is on heartbeat network. Okay. Though heartbeat network is a part of clustering service, but I'm considering it as an important component. Okay, heartbeat network. Guys, what is heartbeat? What is a heartbeat? In simple way, heartbeat is an indication that a component is alive. Am I right? For example, humans, till the time your heart is running, you're alive. In the same way, here in clustering infrastructure, your clustering depends on heartbeat. For example, in Microsoft clustering service, you require 2 NIC cards. One NIC card would be handling the normal network traffic. The second NIC card we dedicate it for heartbeat network. So what happens is that, for example, there are 2 servers required. Why? Because cluster is a group. Group means minimum 2. There are minimum 2 servers required for clustering. So one server is going to check the heartbeat of the other server is also going to check the heartbeat of the first. If first server is not sending the heartbeat, then the second server will come to know that, okay, this server is not sending the heartbeat, that means it is down. Now it has to take the responsibility of offering the services. That is how a clustering service functions. So here in our vSphere HA as well, we require this heartbeat network. Okay, fine. So now let us try to understand the architecture of HA. Now before I go ahead and explain the architecture of HA, let us try to understand how many hosts can be a part of HA cluster. Minimum, guys, 2 hosts. Why? Because cluster is a group, and we configure cluster in order to provide high availability so that one host is going down, the other host can take care of the responsibility. So minimum 2 hosts in a cluster and maximum is 32. So in vSphere clustering service, in your HA, you can have minimum of 2 hosts and a maximum of 32. And how many virtual machines? 3,000 virtual machines per cluster and 512 virtual machines per host. Okay, so this is the minimum and the maximum of our HA cluster: 2 hosts minimum and 32 hosts maximum, 3,000 virtual machines maximum per cluster, and 512 virtual machines per host maximum. Fine.
So,
So
Majid, can you explain the HV network again, please?
heartbeat network,
Yeah.
heartbeat network, guys. The clustering service has this component of checking the heartbeats of one server with another. Okay, suppose there are 2 servers in your infrastructure which have been configured with clustering service normally. In Microsoft, let me compare that with Microsoft clustering service. So 2 servers and I have clustering service on it, and we configure the heartbeat network. One server would be sending the heartbeats to the other, and that is going to respond to it, and the other server is going to send the heartbeats, and they are both checking each other's heartbeat for the responses. If one server is not receiving the heartbeat, then the other server will know that, okay, as it is not sending the heartbeats or not responding to the heartbeats, it is considered as dead, and immediately the other server is going to take the responsibility of providing the services. That is in Microsoft. Now let us try to understand the architecture of HA. How does HA function? Okay. Now here we understood what HA does. The first thing it does is that whenever host fails, the virtual machines are getting restarted on some other ESXi host within 3 minutes. Now we know that clusters are configured, managed, and monitored at vCenter. We configure HA, then we add ESXi host to HA. On every host, an HA agent gets installed. Now this group of hosts which are a part of HA is called as FD, or what is called as fault domain. This HA cluster is called as fault domain. Okay, FD, fault domain. All right. Now, once you enable HA, what is going to happen is that on each ESXi host, FDM service gets started and FDM agent gets started. The entire HA cluster is called as fault domain. Okay, and when you add an ESXi host to HA, and when HA is enabled, on every host, FDM agent starts and FDM service starts. Fine. Now, this entire cluster group of hosts, we call it as FD, fault domain, and this fault domain is managed by a fault domain master host. Now let me explain what is this. Now all the hosts in HA cluster will have master and slave relationship. So that means out of these 4 hosts, one would be acting as a master host and the other 3 would be acting as slave hosts. So this entire FD, what we normally call this entire HA cluster as fault domain, the fault domain is managed by the master host, okay, and the remaining hosts act as slaves. Now guys, how many masters can I have? I can have only one master. Fine. So out of these 4, one would be acting as a master host, the remaining would be acting as a slave host. Now, what is the responsibility of master host? Master host responsibility is to send the heartbeats to the slaves. It is going to send the heartbeats to the slaves, and slaves are going to respond to the heartbeats which are sent by the master. So in this way, master is checking the heartbeats of slaves. Indirectly, slaves are also are checking the heartbeats of master. So this is how HA is going to know whether one of the hosts is down or not. For example, master is sending the heartbeats to three of its slaves. One of the slave is not responding to the heartbeats. Then the cluster HA will come to know that, okay, this host is not responding, and most probably it is not alive. Excuse me. Suppose your master is not alive, it will not be sending the heartbeats to the slaves. Then the slaves will come to know that master is not alive. Why? Because it is unable to send the heartbeats. Okay? Now, we'll try to understand which is the host which would be elected or selected as a master. Guys, this is an election season in India. Let me take the example, this a general example of election. Now we elect our MPs and MLAs, and the people who are contesting for MPs and MLAs, not everyone can contest as an MP or an MLA. Why? Because there is a certain criteria which has to be met. For example, I want to contest for an MP or MLA, I should attain an age of 25. So that is the criteria to contest. Okay, then only I can I'll be contesting, and if I win, then I'll be elected as an MP or MLA. In the same way here, there is an election process which happens between the host, who should be the master, and the criteria to be elected as a master depends on two things. The first one, the host which access maximum number of data stores. Guys, the host which access the maximum number of data stores, that would be elected as a master host. What is the meaning of maximum number of data stores? Guys, what is a data store? We know that ESXi or vSphere has two types of data stores. One is VMFS and NFS. Okay. Now, a host which is accessing the maximum number of data stores, data store 1, data store 2, VMFS shared 1, shared 2, shared 3. In that way, there are different data stores which an ESXi host access. So, the host which is accessing the maximum number of data stores, that would be elected as a master. Now, let us say in my infrastructure, there are two hosts which are accessing the maximum number of data stores. Let us say ESXi host number 1 and 2 are accessing the number of data stores 4. 4 is the maximum number of data stores in my infrastructure. If there is a tie that multiple hosts are accessing the same number of data stores, then the criteria to select the master would be the second criteria. It would be based on the host which has the highest or the maximum number of MOID. MOID stands for Managed Object ID. Object ID, and this is nothing but an ID issued by vCenter server to an ESXi host. There are two criteria. The first criteria is maximum number of data stores. Out of these 4, if one of the data store is accessing the maximum number of it, then that would be elected as master. Suppose there are multiple hosts accessing the same number of data stores, then the second criteria would be taken into consideration. The host which is having the highest MOID or the maximum number of MOID, that is Managed Object ID. This is nothing but an ID issued by vCenter server to your ESXi host. That would be elected as master, and the remaining would be acting as slaves. Clear?
Rajiv, can you just repeat that again, please? Hello?
Guys, there is a criteria which has to be met in order to host to be elected as a master. I told you, all the hosts in an HA cluster will have master and slave relationship. One of the hosts would be acting as master, the remaining hosts would be acting as slaves. Now, who would be the master? There is a criteria who would be the master. The first criteria is the host which accesses the maximum number of data stores. That will be elected as master. In your infrastructure, there might be multiple hosts which are accessing the same number of data stores. Then what would be the criteria? Second criteria. The host which has the highest MOID or the maximum number of MOID, managed object ID. This MOID is nothing but an ID issued by vCenter server to an ESXi host. So the host which has the highest MOID would be elected as a master. Okay? So this is the process how a master is elected and the remaining would be acting as slaves. Now, here I explained you that clustering depends on these three things: clustering service, shared storage, and heartbeat network. Now, it is the responsibility of master to send the heartbeats to the slaves, and slaves respond the heartbeats to the master. In Microsoft, I told you, you require two NAC cards. One NAC card is dedicated for the heartbeat network. But what happens in vSphere infrastructure? We don't require a separate NIC. One NIC is quite sufficient. But which is the network which is handling the heartbeats? Any guesses, guys? Which one is the component on ESXi which would be handling the heartbeat network or the heartbeats, which are being exchanged from master host to the slaves and slave host to the master?
Management port.
Yes, absolutely right. Guys, it is a VM kernel port configured for management. So the management network, the VM kernel port configured for management, is also handling the heartbeat network. Clear? Now, there might be a scenario that only the management network port may be down. Are you able to understand, guys? Guys, my HA cluster depends on heartbeat network, and how we are able to identify that host is down if it is not responding to the heartbeats. And who is responsible for handling the heartbeats? It is the management network. Let us say the VM kernel port configured for management network may be down, but fact is that ESXi host is running and virtual machines are running in the background. There might be a scenario. Then, if HA is only depending on heartbeats network to decide the host is down, then unnecessarily the running virtual machines are going to get restarted on some other ESXi host. Why? Because HA will consider that host as dead or not live if it is not responding to the heartbeats. So there might be a scenario that heartbeat network is down, the management network is down, and unnecessarily HA is going to restart the virtual machines which are already running on some other ESXi host, and it may affect your performance. It may affect your production. Why? Because your virtual machines are running applications and they are unnecessarily getting restarted. So HA doesn't depends only on one, heartbeat network. It also checks something else. So here HA depends on two things: to make sure the host is down, and then it will restart the virtual machines on some other ESXi host. First, it depends on heartbeat network or network heartbeat, whatever you call it as. And the second, it also checks the data store heartbeat. It also checks the data store heartbeat. Now, that means it also pings to the data store, and the heartbeats are exchanged between the data store and the ESXi host. If both these two are failing, then HA will consider that the host has failed. Then it is going to restart the virtual machines on some other ESXi host. Did you get the concept, guys? So HA is going to consider that the host has failed, and it is going to restart the virtual machines on some other ESXi host only if these two criteria are met. The first criteria, heartbeat network or network heartbeat is down, and the second, data store heartbeat is also down. Then only it will consider that host has failed and it will restart the virtual machines on some other ESXi host. Clear? Third, your HA cluster also checks whether your network is alive or not by pinging to the default gateway, which has been configured on your VM kernel port. Now, the default gateway is also called as isolation address. Isolation address is nothing but the default gateway address. Okay. However, HA depends on the first two, but it also checks whether your default gateway is alive or not in order to make sure that the network is up and running. Okay. In order to check whether the network is up and running. However, there might be a scenario in your infrastructure that only the heartbeat network has failed, whereas the data store heartbeat is running. Okay. Or it can be a scenario where only the gateway is down, it is unable to ping to that gateway. Fine. In these two scenarios, if only heartbeat network is down, if only the default gateway is down, then that host is considered as isolated host. Host is considered as isolated host. So, how can I avoid isolated host responses? I can avoid isolated host responses by configuring multiple management network ports and multiple default gateways. So what is the advantage of configuring multiple or redundant management network ports and default gateways is that if one management network port is down, then the other management network port is available so that it can handle heartbeat networks. And if one default gateway is down, there is another gateway so that I can make sure that my network is up and running. So in this way, we can avoid isolated host responses. Till here, the concept is clear, guys. Any questions or doubts before I move ahead?
So, Mujib,
Yeah, Mujib.
One after the other. Yes, yes.
I was saying, if when in case of how do you say, there's no heartbeat detected, so will HA refer to all the different ports and then make a decision?
See, here HA will consider a host as dead only if it is not receiving the heartbeats from that particular host, as well as there is no heartbeats from the data store. That means that host is dead. That's the reason why it is unable to check these two things. Then only that host is considered as dead and the virtual machine will get restarted on some other ESXi host. Clear? This concept is clear?
Yeah.
Yeah. Now suppose if the heartbeat network is down, only the heartbeat network is down. So, but the data store heartbeat is alive, then HA will not consider that particular host as dead. It will consider that host as isolated host. If the host is isolated, then what to be done with the virtual machines which are running and the host which is running? There is a configuration setting in HA where we say that do not do anything to that particular host. I am going to attend it manually, go and see what went wrong, and I'll rectify the problem. So in order to avoid that isolated host responses, what we are suggesting is that better to configure redundant management networks and redundant gateways so that I can avoid this isolated host response. Clear? Clear?
Yeah.
Yep. Anything else? Any other doubt apart from that?
Yeah, Mujib. Yeah, Mujib. This one MOID.
Yeah, manage object ID.
On which criteria it will assign that MOID? Suppose we have 4 hosts.
Yeah, it is based on the first host.
What is the criteria?
Yeah, the first host which gets added to your infrastructure. Okay, that will have the highest MOID. Fine.
Suppose whatever we are adding first host, that
Yeah, that will
might
get
be less
that will get
configuration. Configuration of that might be less, and second host might have higher configuration.
but
Later,
it
can we
doesn't.
change that ID?
No, that ID is generated by vCenter. Okay,
Oh, okay,
that
okay.
ID is generated by
So we can't
vCenter.
change that one.
No, you can't change it. So it is generated by
Okay,
vCenter.
okay.
So the first host which gets added will get the highest MOID. Okay.
Oh, normally in general scenario, so master should be in good position. Suppose one server is with less configuration, another one is highest configuration.
So here configuration doesn't matter. Okay, because normally the host is going down, the virtual machines will also go down, and all it requires is to restart the virtual machines on some other ESXi. Okay, so if you compare HA cluster with the other clustering services, there is slight difference in why that clustering service is used and how HA is being used. Fine? Yeah?
Yeah, thank you. Thank you.
All right. Now, guys, yes, yes.
Yeah, you mean to say the cluster between two ESXi hosts, not between two virtual machines.
No, it is not between two virtual machines, it is between the hosts.
Okay, I have a two virtual machines and ESXi1.
Okay.
One is running DNS, one is running AD. Okay. My virtual machine is down. So what is the position then?
See here, host going down is different, virtual machine going down is different. Try to understand that. Okay?
Yeah.
You got the point?
My virtual machine is down on the cluster.
Now,
it's a down, right? Then
yes.
I needed.
Yes, yes. I understand that, Sadhya. I'm explaining that. That is the second part of HA. I'm coming to second part. Let us first deal with the first part of HA. Clear? I haven't done. I'm not yet done with the entire HA architecture. The entire HA architecture. Okay. So here we understood what is isolated host, and we also understood HA depends on two heartbeat networks. One is the heartbeat network. The other one is data store heartbeat. Okay. Now, guys, we know that cluster is configured, managed, and monitored at vCenter. So the entire configuration of your HA is managed by your vCenter server. And the service of vCenter server. What is the name of the service, guys, of vCenter? Anyone remembers that? It is called as VPXD, right? Okay. Now the entire configuration of this HA cluster is maintained by vCenter server. That is nothing but the VPXD process. Okay. Now this configuration information is passed on to the master host. Let us say ESXi host is my master host. What are the configuration you have done on your HA that is maintained by your vCenter server? Then vCenter server, that is nothing but the VPXD process. It updates that to the master host. Then master host also shares this configuration information with all the slave hosts. So that means every host in my infrastructure has the configuration information of my HA cluster. Clear? Now how do we know that these are the virtual machines which needs to get restarted when the host gets fails? When the host gets fails. Now, guys, let us say I have ESXi2, which is running the virtual machines 3 and 4. So, every ESXi host is going to maintain a list of virtual machines which are to be protected. And which are the virtual machines which will get restarted on some other ESXi host if the host fails? Only the virtual machines which were running. Guys, a host may have 10 virtual machines on it, out of which 5 are running, 5 are powered off. When the host goes down, only these 5 power on virtual machines which went down will get restarted on some other ESXi host within 3 minutes. So, list of protected virtual machines will be maintained by each and every ESXi host, and that list is stored on ESXi host data stores. So every host is storing that information on its data store. Clear? So that's how HA will come to know that, okay, whenever host goes down, these are the virtual machines on that particular host. So when the host goes down, it will clearly know that, okay, these are the virtual machines which has to get restarted on some other ESXi host. Am I clear with this concept? Okay, guys? Clear? Clear? Any doubts?
No.
All right. Now this is the entire architecture of HA. The entire thing what happens in HA. Okay. And now whatever I have discussed here, it is the first part of HA. Why? Because HA provides high availability in three cases. The first case, HA provides high availability against host failures. This is what we have discussed till now. Okay. Now let me discuss the second thing what HA does. In the second scenario, HA provides high availability against the virtual machine or the guest operating system failure. This is what Satya was asking. In the second scenario, guys, host is not failing. Host is not failing. But what is failing? Virtual machine is failing. Just now Satya has asked that, let us say on my host I have my two virtual machines. One is running Active Directory, the other one is running DNS. And if that DNS machine goes down, then what happens? Whether HA can do something with that? Yes. If you enable this feature, which is called as VM monitoring in HA, then HA will be able to restart the virtual machine which went down. In the second scenario, host is not going down, only the virtual machine is going down. Okay. How does this function? Guys, if you remember VMware Tools class, I explained you that when you install VMware Tools, it installs many device drivers and certain services as well. And I inform you that it is going to install VM Heartbeat service, and I'm going to explain this service when I deal with HA topic. Now this is the place where that particular service is going to come handy. Now if you install VMware Tools on your virtual machine's guest operating system, and when you enable this feature of HA, which is VM monitoring, then HA will be able to restart the virtual machines if the virtual machines have failed within specific period of time. Now how this is going to function is that on your virtual machines you have VMware Tools, and in the VMware Tools you have something called VM Heartbeat service. Let us say on virtual machine number 4 I have that heartbeat service. Now this heartbeat service is going to send the heartbeats to the HA agent, which is on that ESXi host. And if this HA agent is not unable to receive the heartbeats from the VMware Tools service within specific period of time, then HA agent is going to restart this virtual machine. So this is the second thing what HA does. It provides high availability against virtual machines or guest operating system failure by restarting the virtual machines on the same host. Why? Because host is not going down, only the virtual machine is going down. And this particular feature or this particular functionality of HA, okay, is optional. If you enable this configuration like VM monitoring, then only it is used, if not no. And in production environment, we do not use this feature, guys, VM monitoring feature. Why? Because we don't know why that virtual machine is down, and prior to restarting it, we want to go and check it out, what went wrong. If there is a requirement, then only we will restart it. Okay, in production environment, normally we do not go and use this VM monitoring. Okay, however, HA has the functionality. Clear with this VM monitoring, guys? Clear? So this depends on VMware Tools. Why? Because when you install VMware Tools, you have this heartbeat service running, and that heartbeat service is going to send the heartbeats to the HA agent on ESXi host. If HA agent is unable to receive the heartbeats from the VMware Tools heartbeat service, then within a specific period of time, then HA will consider that virtual machine as dead and will restart the virtual machine. So this is optional. Now HA can also do third thing. It can also provide high availability against applications failures which are running on top of your guest operating system. So if your application fails, your HA agent can even, your HA cluster can even restart the application which is running inside your guest operating system. However, this is purely optional because it depends on the application support. What is the meaning of it is that your application has to be developed in such a way that it can function along with HA. If your application is supporting HA, then only you can use this functionality of application monitoring, where your HA cluster will be able to restart the application if the application is going down. Clear, guys? So these are the three things what HA can do. By default, HA is going to provide high availability against host failures. When the host fails, virtual machines fail, and they'll get restarted on some other ESXi host within 3 minutes. The second thing what HA can do is that it can provide high availability against virtual machines or the guest operating system failure. If it is not receiving the heartbeats from the virtual machines, VM tools, then HA is going to restart the virtual machines on the same ESXi host. And the third one, it can also provide high availability against application failure, and this purely depends on the application support. Clear? Now let us go through these slides. Fine. So guys, as I've explained you, vSphere HA is a feature of the clustering service offered by VMware vSphere. It is configured, managed, and monitored in vCenter Server. Just now I've explained all the 3 points. Provides high availability against host failures, the virtual machines or guest operating system failures, and it can also provide high availability against application failure. This purely depends on the application support. Now, I also explained you the definition what VMware has given to a cluster. Cluster is a group of ESXi hosts and its virtual machines with VMware vSphere HA and DRS enabled or both enabled. Guys, cluster means group, minimum host 2, 32 hosts per cluster, 512 virtual machines per host, and 3,000 virtual machines per cluster. So let me move forward. Now, as I've explained you the architecture of HA, just a fast overview of it. All the hosts in HA cluster will have master and slave relationship, and when HA is enabled, I told you the entire this HA is called as fault domain. All right. When HA is enabled, what is going to happen? Fault domain manager service starts on each ESXi host. FDM agents also get started. I told you this entire thing is called as fault domain, and this fault domain is managed by the master host. And I also inform you that the entire cluster configuration is maintained by your vCenter server. That is nothing but the process VPXD. So cluster configuration is maintained by VPXD process and is updated to the master agent. That is nothing but the master host. And the master host also shares this information with all the ESXi hosts. Now, which are the virtual machines which are to be protected? That means which are to be get restarted when the host fails. Now that list is maintained by each and every ESXi host, and that is stored on each data store. With this, HA will come to know that, okay, these are the virtual machines which has to get restarted because these were running on so-and-so host and the host has failed. Now, I also inform you that HA depends on 2 things. The first, it checks the heartbeat network or network heartbeat, and it also checks the data store heartbeat. If these 2 are failed, then HA will consider that host has failed and it will restart the virtual machines which were running on that host on some other ESXi host within 3 minutes. That is what I have mentioned here. HA depends on network heartbeats and data store heartbeats.
So here I have a question. So
Yes.
list of protected VMs node recorded on each data store. So what is meant by each data store?
See guys, ESXi host has the data store. Data store means nothing but the hard disk which is formatted with DMFS. So that is maintained on each and every data store. Okay, that list is maintained and that is updated as well. Okay, so whenever the virtual machine is powered on, yeah.
So if a host is accessing 10 data stores, like each host accessing 10 data stores, then it stores the number of VMs on each of them?
No guys, here there is a mechanism, fine, and also inform you about the data store heartbeat, right? Fine, it will check the heartbeats data stores. Now suppose, as you said that if my host is having 10 data stores, then entire 10 data stores would not be checked or used as heartbeat networks. Only 2 data stores are used. So whatever the latest data stores which have been added would be selected as data store heartbeats. Okay, and in the same way, this list is maintained on the local hard disk basically. If you have a local hard disk, local data store on each and every ESXi's data store. Fine.
So it's only local data stores?
Yes, local data stores. Fine.
Okay.
And the entire list is also maintained by the master host. And
But in some networks, people just use the SAN data stores, right? They just ignore, they don't use local data stores.
yes, if you have a local hard disk, then the list is maintained in your local hard disk data store. If you don't have a local hard disk, then most probably it would be on the data store heartbeats. That means 2 data stores are selected, right? To check the heartbeats, that list will be maintained there. Okay?
So every time I add a new data store, the configuration will be updated.
Yeah, that would be
to the
updated.
new
Yes,
one?
whatever the configuration changes you are making, that would be updated, guys. Okay, why? Because the configuration is maintained by VPXD, and whenever there is a change in it, that change is updated to the master host, and automatically that is updated to all the slave hosts in your infrastructure. Yeah.
Okay. So heartbeat status changes to the new one.
Yes.
Right? It
Yes.
goes to the new one. Okay.
Yes. Okay. Yeah. Now here, let us try to understand HA failure scenarios. There might be a scenario where slave host has failed. When the slave host is failed, then the master will come to know, okay, this host has failed, and then immediately HA cluster is going to restart the virtual machines on some other ESXi host. So this we can understand that clearly. However, there might be a scenario where the master host itself might have failed. Then what is going to happen? If master host is going down, then there are only slaves available. Then if master is not available, then immediately a new master has to be elected. So the slaves again will participate in the election, again the same criteria, and whichever the host meets that criteria, a new master is selected, and then the virtual machines which were running on the on the master host will get restarted on some other ESXi host. The third scenario is isolated host. I already explained you what is an isolated host. If the heartbeat network or the isolation addresses are unable to be pinged, then that host is called as isolated host. Then what to be done? We have a configuration on HA, and we normally don't do anything. We leave it as it is so that we go and attempt it manually and try to understand what went wrong. However, how can we avoid isolated host scenario? By having a redundant heartbeat network and isolation addresses. Now let me explain you the fourth scenario here, which is called as network partition. Guys, let us say that in this HA cluster, I have 4 hosts.